The physical interaction program is researching how robots interact with the world, and that can be whether within the natural environment, the built environment, or even off-world.
We're very much interested in how the robots, by the very name physical interaction, actually interact and touch the world. So, some robotics, like driverless cars, for example, is about moving things around. But with physical interaction, we're interested in tasks like where robots maybe pick something and manipulate things, where they may be doing something on metal work. We've got examples of a thing called linishing, where a robot is actually putting a pattern into some metal.
The types of research that we're doing range from fundamental research around how robots physically observe the world in order to manipulate it, all the way through to developing manipulators that provide those forces and either pick fruit or move objects, fold clothes, all the types of tasks that we take for granted, but is quite difficult for robots to do.
So this is Harvey. Harvey is an autonomous capsicum picking robot. And so we built this robot from at QUT to autonomously pick capsicums in a real greenhouse environment. And so it does this by actually using a depth camera on the end of its robot arm to see the fruit and then pick where to actually cut it free from the plant. And it does this autonomously and intelligently. So this idea came about from a funding program from the Department of Agriculture in Queensland. And so they were looking at ways to help farmers use robotics to improve their harvesting and improve their work. So we looked at, well, what was the big challenge in Queensland? And one of them was actually capsicums. And they're actually quite a labour-intensive process to remove capsicums from plants. And we thought it was the right time to look at how robotic arms and robotic platforms can do that autonomously.
So one of our use cases that we're trying to help people with is in metal finishing. So currently a metal finisher has to hold a tool, and it's usually relatively heavy, and it's back-breaking work where they may be leaning over or leaning up and spending many hours doing something. And they can get injured, or they can get tired, or they need physiotherapy, those sorts of things. So we're trying to develop tools for those people. We're not trying to remove their job. We're trying to give them a new tool, which is actually a robot, instead of their old tool, which is a hand tool.
So while we build robot systems, we do it because there's nothing out there at the moment. But what is core to this is the algorithms, the image processing, the manipulation tasks, the path planning, all those fundamental research items that translate across all our applications. And that's the key to this type of research, is to make sure that it is general enough that we can apply it to so many different problems, ones that we know about now, but ones that we might come up in the future.
My research field is artificial cognitive systems. So how you get a system that can perceive the world around it, how it takes this world around it and makes a model of it, how it can then use this model to reason about what it should do next. So what decisions does it need to make? Then also to learn, if it's made a bad decision, well, how does it make a better decision in the future? And then we go on to how it actually acts in this world. And this is the point of this research theme, how we do the physical interaction.
So I'm actually working in a slightly different area, looking at vertical farming systems and how robots can help manage crops on vertical farms. There's an issue in agriculture where our population growth is becoming quite large, and we need to be able to feed that world. So we need to look at alternative ways to grow food in urban or on top of buildings or in vertical farming spaces. I'm particularly interested in agricultural environments like indoor environments where robots are actually can be quite well suited because it's protected from the rain, protected from the weather. So you get this double benefit of robots being able to manage crops and the crops are protected from the environment. We've got students on this, we've got colleagues of ours, professors on this who are very interested in trying to help solve some of these real world problems with how do we grow crops to feed the world.
We have new opportunities with new research programs. For example, now we're going to be working in the Antarctic. We're going to have rovers that move around and collect physical samples. We have underwater robots that are actually going to be under ice, collecting physical biological samples. We have to be super delicate with this. But because it's so remote, we need to create these systems to not only pick things up, but make decisions about what they pick up. These are environments that aren't very conducive to having humans there. And this type of research will translate to space exploration. those types of things, off-world mining, all sorts of things that require all different levels of robotic systems from all our research platforms. This is just one component of that that's going to deliver the robots of the future.